Okay, I think we got this previously, but just in case, if this point is x1a, where x1 is just x over the square root of r, of course I didn't use that here, but that's what x1 is, right? Okay, then what's theta? Well, clearly from this right triangle, the run here is x1 minus x, the rise is a, so we have the arctangent of a over x1 minus x. And then we've got to add 180 degrees if this run here is negative. In other words, if x1 minus x is less than 0. So now we ask the question, what's the direction perpendicular to the line joining these two? And what's the direction perpendicular to the line joining these two? And I'm going to do it in terms of vectors. There are other ways to do it and get the same conclusions. This direction is clearly the I direction because these things are the same x-coordinate. That's got to be a vertical line. Normal to that is the I direction. Okay, over here, well, we've got the angle theta is going to be here. This is the angle. This is going to be theta. And you can use high school geometry, similarity, and what's perpendicular to what and what's parallel to what to determine that that's got to be theta, which means that let's just say that we're going to specify this by a vector with I in this direction and some multiple of j in this direction. Okay? That multiple I'm just going to call negative m for reasons that will become apparent in a minute. Okay? So that just very straightforward, the tangent of this angle is then going to be 1 over m. So m is x1 minus x over a, just, well, okay. M is going to be 1 over tangent theta. Theta is the inverse tangent of a over x1 minus x. So m is going to be x1 minus x over a. Then this vector, resultant vector, the vector that we have here, the vector in the direction perpendicular to this, is I minus x1 minus x over a times j. Okay? Okay. In any case, the question then is, where does this vector intercept the x-axis then? What are the coordinates of this point? Now remember, x1 is just x over the square root of r, and we'll get that in a minute, okay? We can substitute that in, so we can take this back to our original parameters, but what are the coordinates of this point?